Assalamualaikum and hi everyone. This is my presentation for semester May 2025 for subject GDB 1023 Fundamental of Geophysics. My assignment title is Seismic Exploration Technique in Mining and Oil and Gas Industry. This presentation was presented to my lecturer, which is Associate Professor P.S. Dr. Hassan Sunamani. First of all, my name is Nur Qurratu Aini. My student ID is 2400272 from Bachelor of Science in Petroleum Geoscience. So now, let's begin with the introduction. Exploration technique help geoscientists find oil, gas, and mineral underground without having to drill first. Methods like seismic and gravity survey give a clearer picture of what is beneath the surface, saving time and cost. Seismic exploration is mostly used in oil and gas industry because it gives detailed image of underground rock layers and possible oil traps. Meanwhile, gravity methods are more common in mining to detect large heavy mineral deposits. Seismic exploration started in the early 1900s with the first oil survey done in 1921 in Oklahoma, USA. Today, it is one of the most reliable geophysical techniques. In short, seismic waves are sent into the ground using energy source like explosive or vibrosive trap. These waves bounce off different layers and return to the sensor at the surface. The data is then processed into images that help us decide the best place to drill. Besides oil and gas, seismic methods are also used in groundwater studies, civil engineering, and environmental works. In this presentation, I will explain how seismic exploration works, the type of the survey, how the data is organized and interpreted, and share a case studies. I will also briefly compare it with gravity method and end with a conclusion and recommendation. Now, let's take a look at how seismic methods are done in the field. Seismic exploration works by generating and recording seismic energy, or in simple terms, sound waves. These waves travel underground and behave differently depending on the type of rocks or fluid they pass through. The two main seismic methods are refraction, where waves bend as they pass through different layers, and the another one is reflection, where waves bounce off rock layers and return to the surface. Both methods help geoscientists understand the structure beneath the ground. In oil and gas, reflection method is more commonly used because it provides more detailed image of the layer. To understand how seismic method works, we first need to know the type of seismic wave used in the process. There are two main types, which are P wave or primary wave. There are compressional waves that travel the fastest. They can move through liquid, solids, and gas. Apart from that, there is S wave or secondary wave. These are shear waves that move slower than P wave. Unlike P wave, S wave can only travel through solid. By analyzing how these waves move through different layers underground, geoscientists can learn a lot about Earth structure. Now, let's take a look at the main type of onshore seismic source which are used during land-based survey. There are three common methods, which are first, explosive or dynamite. This method is used for deep survey and gives high-resolution results. The process involves drilling a short hole, placing an explosive charge inside, then backpiling the hole for safety. After detonation, the reflected waves are recorded by geophones. The advantage of dynamite is that it creates strong, sharp waves that give clear image. The disadvantage is that it requires permits and very strict safety rules. Next is vibrosive or vibrating seismic traps. This method is common in oil and gas survey, especially near the desert, flat area, or populated regions. Trap with a metal pad press down and vibrate the ground in control suite. Geophone then record the earth response. The data is later correlated with the known sweep to remove noise. The advantage is that it is safe and non-explosive. The disadvantage is that it is less powerful, so it doesn't work well in hard rock or deep target. And lastly is weight drop system. This is used for shallow survey like groundwater or geotechnical studies. A heavy weight is dropped onto a base plate to create seismic wave. It repeated several times at each spot, and the signal are stacked for better quality. The advantage is that it is cheap and simple. The disadvantage is that the energy is low, so it's not suitable for deep imaging. Next, let's talk about offshore seismic sources, which are used in marine-based survey. Air gun are the most common source for 2D, 3D, and 4D seismic survey in both shallow and deep water, especially for oil and gas exploration. The process starts where several air guns are arranged in clusters to produce strong energy. Then comes the firing step, which is high pressure air up to 2000 psi is released underwater, forming a bubble that collapses violently and creates seismic wave. Next is synchronization, where the air gun fire every few seconds and their location and timing are tracked using GPS. Finally, hydrophone, which are sensors placed in long streamers behind the survey vessel, will record the reflected wave. These recordings are then sent to the server for the quality check and storage. The advantage of air gun is that they are really powerful and reliable. The disadvantage is that their potential impact on marine life, so environmental monitoring is always required. Now, let's move on to seismic survey, which are the main operation in seismic exploration. This survey can be done either onshore, which is on land, or offshore, in the sea. The process involves using different seismic sources to send wave underground and then using receiver to record how those waves bounce back. This helps create detailed image of underground rocks, layers, and structure. For onshore survey, everything is done on dry land using truck-mounted equipment. Here are the main steps, which is first, survey planning. Geophysics plan the survey line based on the geology of the area. Source development, seismic source like vibrous rock, dynamite, or wave drop system are used depending on the terrain and depth needed. Receiver placement, an array of geophone is placed along the survey line to record the wave reflected from underground. Next, data recording, which is as the wave return, they are recorded and checked for quality and clarity. Now, let's take a look at offshore seismic wave, which are done in open water with special vessels and marine equipment. Here are the main steps. First, streamer deployment, where long cables called streamer containing hydrophone are tied behind the survey ship. Next, source firing, which air gun release bursts of compressed air at the regular interval to generate seismic waves. The third step is data acquisition, which is the hydrophone record the reflected wave that bounce back from subsurface layer. Next, navigation and synchronization, where GPS and onboard system track the exact position of each shot, and lastly, receiver to make sure the data is accurate. Once data is collected from the field, it goes through a process called seismic data organization. This means we capture, arrange, and process the seismic signal in a way that helps us clearly understand the underground geological structure. Good data organization ensure that the signals are clear and accurate, which is very important for successful seismic interpretation and reservoir analysis. One of the most important parts in this process is the receiver. A receiver is a device that detects and records the seismic wave that return from the subsurface. It turns ground vibration on land and pressure changes in water into electrical signal for analysis. There are two main types of receiver, which are geophones that are used on land. These are placed directly on the Earth's surface and can detect vertical or horizontal ground movement. Inside, they have a coil and magnet system that create voltage or motion. Geophones are used in onshore survey. Next is hydrophone, which are used at sea. These detect pressure changes in water caused by the seismic wave and especially from air guns. Unlike geophone, hydrophone respond to acoustic pressure. They are usually installed in streamer or placed on the seafloor during the offshore survey. Next, there are three main types of seismic receiver array. The first one is 2D array, arranged in a straight line used for basic or low-budget survey. They give a vertical cross-section but no full 3D view. Next is 3D array, which they are set in a grid pattern to cover both X and Y axes, used for creating full 3D images of the subsurface that is ideal for oil and gas exploration. Lastly, 4D arrays, which are same as 3D, but they repeated over time to monitor reservoir changes. They are most useful for reservoir management and enhanced oil recovery (EOR) planning. In seismic survey, how we design the receiver array affect the quality of the data we get. Here are three key parameters, which the first one is spacing. This is the distance between each receiver. Close spacing gives high resolution, good for shallow target. Wider spacing is better for detecting deeper structure. Next is aperture. Aperture is the total length of area the array covers. A larger aperture helps capture wave from wider angle, improving deep reflection, detection, and overall coverage. Lastly is geometry. This refers to the shape or layout of receiver setup, like linear, grid, fan shape, or zigzag. The right geometry depends on the terrain and survey goal, and it helps reduce noise and improve data quality. Next is seismic data is organized in three key phases, which is first one is acquisition phase. In the acquisition phase, there is metadata recording, which log field info or records such as source, layout, and timing. Next is coordinate assignment, where they assign GPS or UTM to all sources and receiver. The next phase is processing phase. There is few things in the processing phase such as trace sorting, where they group data like CMP and shops. And next is quality control, where they remove the noise and error. Next is they format the conversion, which they convert to SEGY and update the header. Last phase is interpretation phase, where there is structural and stratigraphic. Structural, they identify the faults, fold, and fracture, while for stratigraphic, they analyze the rock layer for reservoir prediction. Next, we are going to talk about the interpretation of the seismic data. Seismic interpretation helps identify subsurface geological features to guide drilling and reduce exploration risks. It is crucial for locating hydrocarbon traps, predicting rock and fluid types, and also planning the field development. The first one is structural interpretation, where they analyze fault, folds, and reflector pattern to map reservoir geometry and estimate the trap size. Next is stratigraphic interpretation, where they examine the reflection pattern to understand the sediment layer, depositional history, and identify the potential reservoir and seal rocks. And lastly is amplitude and attribute analysis, where they use variation in the seismic amplitude to infer rock properties, as example porosity and lithology, and fluid content in the subsurface. Next, we are going to talk about a case study, which is Joshua shale gas field. This case study highlights the use of high-precision 3D seismic technology in exploring the Jiaoshiba shale gas field in China, Sichuan basin. Due to complex geology and thin reservoir, traditional 2D methods were ineffective. The use of 3D seismic helped accurately locate the shale gas, which is recalled as sweet spot, by improving the imaging of subsurface structure and identifying key properties like organic content and fractures. As a result, Sinopec achieved commercial production in well Jiaoye 1, showing the success of this approach. This case proved that advanced 3D seismic is crucial for the shale gas exploration in challenging terrains. Next, let's compare the two exploration methods, which is seismic and gravity. Seismic method offer a high-resolution 3D and 4D imaging, which makes them excellent for detailed subsurface analysis. However, they are expensive and require complex equipment and processing. In contrast, gravity methods are low cost and great for covering wide area quickly, but they have a low resolution and provide less information about the depth and fine geological structure. So, seismic is more precise, while gravity is more budget-friendly for the large-scale survey. In conclusion, both seismic and gravity methods play important roles in subsurface exploration. Seismic methods provide detailed, high-resolution of 3D and 4D imaging, ideal for identifying and monitoring hydrocarbon reservoir, but they are costly and require expert interpretation. While for gravity methods are more cheaper, quick for wide area survey and non-invasive, but they have lower resolution and depth accuracy. So for the recommendation, it is advisable to use gravity survey in early stage to map the large geological features affordably. Then, we have to apply seismic survey for detailed analysis, especially 3D or 4D for oil and gas target. Combine both methods with geological data to improve accuracy and reduce uncertainty. For complex environment, pair gravity with vibrosis-based seismic to reduce impact. And lastly, we have to invest in skilled geophysics and quality software to ensure accurate interpretation. Together, these methods form a powerful toolkit for smart, efficient exploration. So, that is the end of my presentation. Thank you.